So in order to create and to derive streams for our study area from them, we should create a mosaic for our mosaic of flow direction for our study area. So if you just deleted your flow direction or didn't save it, the mosaic, don't worry, we will repeat the same steps again. So I'm again just dropping my digital elevation models to my model maker, and I will use again fill tool to just smooth my study area digital elevation models in order to create flow direction. So let's choose one by one. So this is 171. You can save it in your folder. So and name it. Do not, if you're saving in a separate folder, do not forget just to write the extension. .tif. So when we will finish fill operator, we will use again flow direction tool. This again from hydrology toolset. Just drop this function 5 times, and we will connect it with this field image, flow direction 1.tif. So this one. So we should create flow direction initially for the first each image separately. Otherwise ArcGIS might find an error. So you might think that it would be easier just create a first mosaic and then just derive from the mosaic field mosaic dataset flow direction, but ArcGIS doesn't often finds mistake, error, or just hardly process and execute data that is mosaicked. So it is better to work with separate field images rather than just trying to calculate flow direction for the mosaicked image. And the next thing is this mosaicing. So go to data management tools, raster, raster processing, and raster dataset, and mosaic to new raster. So we will now mosaic this flow direction image 3, 4, 6. So just a minute. Yeah, that's correct actually. It's number 5, not. So yes, number 5, output location flow direction mosaic.tif. Oh, sorry, I should find the folder. and flow direction mosaic.taf with extension raster dataset name. It's unsigned 8-bit, number of bands 1, it's a monospectral band, don't forget. So number of bands 8 bands, partial reference system will not change it so far, so click OK. So I will create first field, then flow direction, and then mosaic them. So at first validate your model and then run. So it's running step by step. So my model is completed now. I can edit. So it's my flow direction, and also we should add now flow accumulation. So it's my flow accumulation, remember, and which I derived from flow direction. And I need to extract values which can be considered as streams, pixel values. So if you will zoom to closer to the flow accumulation, you might see that certain areas, certain pixels have high values, see, white color, so they accumulate water and deposition. So I need to extract these values. In order to do this, at first I should understand which values I need to extract. So I will just go to classify and reduce the number of classes into 2 and click OK. So see, it automatically starts to divide. Let's see. So this is from black is from 1 to million and above million. So these are the biggest major streams, but I think that these values are too large. Mostly you know that experts suggest to take into account as pixel streams these values starting from 8, so above 8 and start more than 8. So see that this now I have much higher amount of streams. So I can also rate it until 10,000 because I don't need all streams, I don't need small streams, only the major ones. So now I want to extract them to only values starting 10,000. So I choose flow accumulation more than 10,000. So okay, so it's extracting only pixel values that have higher than 10,000. So I don't need this one anymore. So I have these streams, pixel streams, but the process is not over. I need to go to hydrology and go to the stream order. I need this file function stream order, and as input stream raster I will choose this one which I created, and as flow direction tool raster this one, flow direction, which I just derived. So as a method of stream, this one is st rachler, is the most famous and widely used. So again I can choose this streams, so it will be in raster format. And click OK. So my streams in raster format are ready. See, so these are the major streams. So this is the first order stream, second order, and third order stream. So the next step will be to just calculate Euclidean distance for the study area for each stream. Hey guys, if you liked the video, please consider supporting the channel by purchasing online courses via my Udemy's profile, JS Lab. Here you can find multiple courses regarding JS remote sensing. The link to the profile is below.